Once we've filled out our truth table, the next thing we want to do is to be able to read off results from our truth table. The first kind of result that we want to look at is using our truth table to determine what kind of formula a given logical sentence is. There are three kinds of formulas, and we'll talk about how to test for each of them. The first formula that we're going to test for is a logical truth or a tautology. So a logical truth or a tautology is a logical statement that relates the simple statements in such a way that the formula as a whole can never be false. It is always true no matter how the world is. And so to test to see if a particular formula is a logical truth or a tautology, we look under the main connective. So let's say we'll check this formula. Look under that main connective, the tilde, and then we check to see if that formula is always true. So that first row, the third row, and the fourth row are true. But this fourth row shows us that this formula can be false. So it's not a logical truth or tautology because it is not always going to be true no matter how the world turns out. The next kind of formula that we're going to test for is a logical falsehood or a contradiction. So an individual formula in our language can be said to be a logical falsehood or a contradiction if it's impossible for it to ever be true. No matter how the world is, that formula will be false. So if we want to test for logical falsehood, we'll look under the main connective. So let's say test this one. We'll look into that main connective here, the disjunction or the wedge, for the truth value for that whole formula, every different way the word could be. If it's a logical falsehood, then it will be false for every row under that main connective. So when we look under that main connective here, we can see that there are more than one row even that this formula turns out to be true on. And hence it is not a logical falsehood or a contradiction. So even though none of the formulas on our truth table here are logical truths or logical falsehoods, there are examples of logical truths and falsehoods on the slides for the propositional logic lecture, so you can look at those if you want to see examples of sentences that satisfy those two properties. The last property that we want to look at is contingency. A statement is a contingent statement if it's possible for that statement to be true and possible for that statement to be false. In other words, its actual truth value will be contingent on the way the world is, the truth values for simple statements. So for instance, let's look at this biconditional here, our triple bar. We look under that main connective, we go down this row. If it's a contingent statement, then there'll be at least one way for this statement to be true. And there is. Here's a way. Here's another way. If it's a contingent statement, there will also be at least one way for the statement to be false. And there is. Here's a way for it to be false. Here's another way for it to be false. So this statement, P triple bar Q, is a contingent statement. It's possible for it to be true, and it's possible for it to be false. If we look at each of the other formulas on our table here, we notice that there's at least one row where this first formula is true, and at least one row where it's false. And so this is a contingent statement. Look over here at our wedge or disjunction. There's at least one row where it's true and at least one row where it's false. And so it too is a contingent statement. Finally, under our horseshoe or conditional, there's at least one row where it's true and at least one row where it's false. And so it too is a contingent statement. So now we've seen how to determine whether a individual logical formula is a logical truth or a tautology, or it's a logical falsehood or a contradiction, or it's a contingent statement. Every formula will be one of these three. You just have to remember what the pattern under that main connective has to be in order for it to be one or the other or the third. Now let's turn to relationships between statements. The first relationship we want to look at is the relationship of logical equivalence. And two statements are said to be logically equivalent if they always have the same truth value. So every different way the world could be, they will have the same truth value. In other words, for every row, the truth values under that main connective will be the same. So let's look at, for example, this formula and this formula. So we're going to look under our tilde, the main connective here, and under our horseshoe, the main connective here. First row, they're both true. The second row, they're both false. Third row, they're both true. And the fourth row, they're both true. So these two formulas are logically equivalent to each other. They always have the same truth value. It's impossible for them to have different truth values. Hence, they're logically equivalent. The next relationship that we want to look at between simple statements or individual statements is the contradictory relation. And the contradictory relation holds between two statements if they always have opposite truth values. So logical equivalence, they're always the same. Contradictory, they're always different. So let's say we look at the triple bar here and we look at the disjunction here. We look into those main connectives and we ask, are the truth values always different? So these two statements, that first row there, they're the same. They're both true. Hence, these statements aren't contradictory. Likewise, this row here, they're both the same. Hence, they're not always opposite. Hence, they're not contradictory. If you want to see an example of a truth table that shows a statement to be a contradictory statement, you can look on the slides for the propositional logic lecture. Next, we want to check to see if a statement is consistent. Two statements are consistent. Two statements are consistent if there's a way for them to be true at the same time. If there's at least one way the world could be where they're both true, then they're said to be consistent. So to test for consistency, we look into the main connective, the two formulas, and we see if there's a row where they're both true. So let's take our horseshoe here, and let's take our triple bar here, our conditional and our biconditional, and see if they are consistent. So we look into those main connectives. First row, the biconditional is true. First row, the conditional is true. So these two statements are consistent. It's possible for them to be true at the same time. There's at least one way the word could be where they're both true. Hence, they're consistent. Now, statements that aren't consistent are said to be inconsistent. Those statements are such that there is no row where they're true at the same time. Now, that doesn't mean they're contradictory, and it doesn't rule out them being logically equivalent. What it says is that there's no row under a main connective where they are both true at the same time. So if we look at these two formulas here, we see that there's a row where they're both true, so they're not inconsistent. We look at these two formulas, we see there's a row where they're both true, so they're not inconsistent. We look at this formula and this formula, we see there's a row where they're both true, so they're not inconsistent. So if you want to see a truth table where two formulas are shown to be inconsistent, I believe there's an example of that on our lecture slides for propositional logic lecture as well.